Welcome to Model 19, Supervised Machine Learning Regression. In this model, we'll describe the stepwise regression methods. In order to have a better understanding, a clear understanding about stepwise regression methods, we present a case study concerning the tank corrosion remaining useful life prediction. As usual, in the beginning of each model, we present a glossary with the main concept of artificial intelligence, machine learning, unsupervised machine learning, supervised machine learning, and the different types of supervised machine learning. That is, supervised machine learning classification and supervised machine learning regression. Concerning the different methodologies, technologies that we have in artificial intelligence, in this training we focus especially in two types of machine learning methods, the deep learning and the machine learning. As we already explained, the general concept of machine learning is since you have a data set, you split your data set in training data and test data, let's say 70% and 30%, then you pre-select a model. In this case, we are going to see the stepwise regression method, and then based on the 70% of the training data that is a random select from the data set, we'll train in the model. Then by the end we've got an error that we are going to compare with the test data that's applied the same model. And then if the error is acceptable, we can use a new data set in the same context that we had on the first data set. And then if the error is again acceptable, we can validate the model. The regression model, we use a data set with predefined values concerning dependent variable and independent variable. For example, if you have a corrosion thickness measurement and we want to predict the function of failure when the corrosion achieves the thickness limit, we have this data set of all information. Then, of course, we want to have a regression model. What's the regression model do? They will predict the future thickness of corrosion in order to predict when and which time this thickness will achieve their limit. So, and that is the general concept that we have when we apply the regression. In this specific case, we will use the stepwise regression method. And then, of course, we follow the similar step that we have in supervised machine learning regression. That is based on a data set. We split the data set in training and test data. We use the training data to train the model. Then we verify the error. We use the test data to verify again the error. And then we'll come out with a new data set to validate our model. Concerning linear regression, concerning supervised machine learning regression, we have different models of regression. We already saw the linear and hidden and lasso regression, and now we are going through the stepwise regression methodology. In the end, we will be able to predict the remaining useful life based on corrosion thickness in the tank. So now let's present the stepwise regression methodology. The stepwise regression methodology have some steps that you need to implement one by one in order to define the independent variables that will be part of your regression methods.
What's happened actually when we have a linear regression, we can have a multi-linear regression, and that means that we'll consider a lot of independent variables. For example, if we have a tank, we can consider different regions of temperature. We can consider the pH, acid pH inside the tank. We can consider the cracks values, the pitting values. And the point is, when you have a lot of these independent variables, which are the most important for our prediction, which one have more relevance for make prediction of our dependent variables. In our case, for example, consider a tank. it's not better to get only the thickness of the corrosion or pitting rather than getting also the temperature inside the tank or the pH of the inside the tank to predict our remaining useful life. So that is the question. In stepwise regression method, what this method do is to define which are these independent variables or predictors that are more important to use in our prediction. So the first step that we do is to consider all the predictors. Then we start with one very simple linear model that goes to the center, and then we start to add one by one the stressor, and we want to find these values in here, these parameters in here. So in the second step, we will add one variable here. So, but we have, for example, depends on the case, we can have 10 type of variable or 5 different variables to add in our equation to make the regression. So in the first step, we add only one. So we have different options. We can add, for example, this x1, we can add x2, x3, and so on. What we're going to do is to calculate the t-statistic is and p-value for each one of this possibility, and get for each one of them, we see here x1, x2, x3, x4, x5. Then for each one of them, we calculate this parameter here of the equation, and for each one of them we have a t-statistic and a p-value. So here what I suggest is to use the t-statistic, and the one that have the higher t-statistic will be the one to go into this equation. So that means if I choose x3, the equation will be these parameters will be this equation here. So alpha 0 plus alpha 3 plus alpha 3. Why? Because when compare t values from different predictors, the x3 are the highest one, and then I put the highest one. And then the next step, I will go the same, but we'll do again regression, but now I use this equation, and again we'll add the third terms here, and we'll do the regression again to get the t-statistic and get the second one, and I will go further and further until my p-value here limits, and I will be satisfied for the limits of number of the error that I want to have in my prediction. So what's the t? What means this statistic? So t statistic is the ratio between the estimated parameters divided by the standard error, and p-value is the t statistic for hypothesis test that's we use for coefficient equal to 0 or not, or close to 0 or not. So basically, when we have here lowest value for these parameters, means that they are not significant for the prediction. So here we can see we have a high value. That's a p-value. And when we have higher t statistics, that's the one that we choose. So by doing that, we are starting to here we build the first the second terms, the first terms in this equation that we choose x3, and then we go to the next step. Now we have this equation that we used previously, and then we need to add another predictor. So we already have x3, so we can have different combinations. So this one using x2, this one we can use x4. We do not use x3 again, we use x5, and so on. And then we repeat again the regression for each one of these equations. In the end, we get again this table that we get before, with p-values and with p-values and t statistics, and then we have a new equation. By then we will add new predictors, and we always are adding the new one. Okay, So here I have an example that we want to predict remaining useful life, and the prediction are temperature, corrosion in millimeters, and pits in millimeters. So in the end, when apply the MATLAB model to make this algorithm, use this algorithm, and by applying MATLAB, the solution that the software gives me are that the corrosion are the variable that is the most important. Then we can see the absolute value here is high, the p-value here, and then we have this equation. And then this equation, by getting the value from here, alpha 0 and alpha 1, we can apply this equation to predict the remaining useful life. So it's a very simple case to make it clear and understanding. So if I'm happy with the solution, and then I can predict my remaining useful life. So the model, they get root mean square error of 93%, and that's a representation of the difference about what the value and what is the true value and what is predicted by the model. So we get this value here, and how we get this value is based on applying the MATLAB software, or even use some other language such R language and others.
So the final solution is to have a regression model that enable us to predict the remaining useful life based in the corrosion thickness increasing along the time. So that's the basic of that's the main objective of our case study, and we're demonstrating that in a practice case study by using the MATLAB software. So in the end, we have different variables, independent variables. We are able to identify the one that's more influence, more important, is more correlated with remaining useful life, and then of course based on it, we have a regression model that are able to predict the remaining useful life based on the corrosion thickness. So now we are going to perform a case study in the MATLAB, and we use our software as we already demonstrating before to get our regression model based on the stepwise methods. So in order to implement the codes in the MATLAB, implements this gets this result of the regression model for predict remaining useful life based on corrosion, we need to implement this specific code in MATLAB with similar that we had before with specific comments. So the first line here we'll just read the database that we collected information. Then we split our database in 70 and 30%. 70% of this database are random data from the data sets that are for training, and the other 30% are for tests. Then I need to define the data train matrix here for collect the training data, and that will select 70% of the database random, that will make a random selection of the database concerning 70% of the number of information that I have here. And then after that I do the same, but for test data I create a data test matrix that get 30% random data from my data set. And then of course I start to implement my training for stepwise model. So in the first step I will train the whole data set and make a prediction for a whole data set. Then are you training the data train only and make prediction for the regression, consider remaining useful life for consider only the 70% of the data set. That means using the data train. And then I make training the data set for a data test, and then I make a prediction. In the end I can plot different models and see the regression model. And then of course, as we usually do, we are apply also this model by using the APP, the applicative in the MATLAB, and then we get the prediction functions that's from the stepwise model. And then based on it, we are validate our model by using new data sets and verify the error. So let's move to the software and implement this code step by step to see how does it works. Our first step here in the MATLAB will be to import the data sets. So let's take a look on our regression files with stepwise regression case study. So here we are. We import the file 2, and the file 2 will have we can see 3 independent variables such as pitching, thickness, corrosion, and temperature. Then we want to predict. We have some remaining useful life prediction based on these values, but actually what we want to do is to find out which are the relevant independent variables and to have a more precise a regression model. And that's by using linear regression, we are not able to do that, but by using the stepwise methods, as I explained before, stepwise methods enable to select the independent variable that's more influence and more important for the model is. So now what we're going to do is create the matrix A. Let's read the file tank2, and now the next step is to split the data set. So what we're going to do is to split our data set in training data and test data. So here we are, we split our data set in training data and test data. Now we'll create the matrix data training and test training that will select random data from our data set. So we include the command for data train. So the data training have 10 of data from the data set that we have here 19. So if you look on here, we will have random data that was selected for our data set. So for example, we can see that the first line here is not the first line that we had here. The second line in the data training is something in here. Yep, this one, and so on. And now the next step will to create the data train file. Sorry, the data test file matrix. So the data train we already created here. Now what we are doing, we are creating the data test. And the data test that we can see here have 30% of the data sets, and we have only 3 lines that are random selected from our original data set here. Okay, the next step now is, since we have already our partition, have split our data set in 70-30% for data training and test data and data test, we are starting the command training the data set. So now I include 3 training commands. So the first one consider the whole data set, then we consider all data sets. Again, is important. The machine learning process is, of course, to split the data, the training, to use it in the training process, the data training. But I just want to show the difference by training the whole data set, the training data sets, and the test data sets. That's why I'm doing that. So I will create the MDL file. So the MDL file was created here, and you can see that the answer come out here, demonstrating that they add the corrosion independent variable. So that means that this regression method we use only this corrosion to predict the remaining useful life. So now let's make some prediction about the remaining useful life by using the corrosion that is the independent value. And see here we can see some statistics, p-value and f statistics that we've got from this data. Now we're going to make a prediction. So you see a prediction from the MDL, the model that we're training here. And then we can check the prediction in here, the first prediction and compare this remaining useful life values that we have here by comparing this the first values that we had, and then we can see that we have quite a small error when we compare the two values. And then of course the whole idea is to use these functions that predict the remaining useful life for a new data set. A very important information is when we are training our model is to look on these coefficients here. And this template shows the coefficients, let's say for our regression, linear regression line, that are the alpha 0 and alpha 1 that we use to predict the remaining useful life. So this information, this template here is very important, as well as the standard error, the t standard, the p-values that you have. But these two parameters here are the ones that we use in our equation later on when we want to predict. And then these parameters are the one that are used in here to predict these values. So very important to know that how we can get these parameters of alpha 0 and alpha 1 from our line function. But let's go step by step. Let's now training the model by using the data sets, the data training. That is 7% of our data set. So let's include here now the training command for stepwise model for data training. So here we are. Then we can see the MDL in here, and then for data training also we've got the corrosion. We have a different p-value here, very low, close to 0, and the f-stat statistic here. And now what I'm going to do is to predict the remaining useful life based on the stepwise, what's the stepwise model defined for the training data set. So considering that we have now these data training, the 70%, those are this one here. So we've got a prediction. So we train our model, then we've got a prediction. We already have, this is MDL, is the data training, and here is the prediction. So if we just copy in here and let's say put it in MDL1 and not in MDL1 and data train 1, so we can compare the previous values that we had with the values with let's say remaining useful life that we're using for training. So it's very there are very approximate values that we've got here. So just let's say cut in there, and then of course we can do the same for a training data set. So we perform a training for a test data set, for a test data set. So we perform a training and prediction for the, let's say the test data set. So here we are, our MDL. So there's no terms add to or remove for the data set. It's very small quantity of data, so probably I will not get any results. But here they are considering all, I think, consider all independent variables. So let's check it out. Then let's check it out the prediction for a data test. So here we have the prediction. So here we are. Those are, we have the same prediction for remaining useful life. So of course this test data set is very small, so it's not a reliable sample to make any regression. But we saw that when we using the training data sets, we've got a good regression. Now what we can do is to plot the different regression lines to see how is the behavior of remaining useful life prediction, the line, how does it works and how this the behavior concerning the corrosion. When the corrosion increases, the remaining useful life decrease. So the first MDL is the one that have all the data sets, and then we are able to plot this MDL graph here just to present the results. So here we have the corrosion and the remaining useful life. So we can see that this straight line represents the let's say the regression line that will be used to predict the remaining useful life. And then of course we can also plot the MDL one that's considered the data train, the 70% that was selected for data train. You just need to create a new plot, then they will plot the one that is for a data train. So you can see that there are a smaller number of data, of course 70% of the data set, but also we've got the picture that shows the regression model, and that's predict the remaining useful life when the corrosion increase along time. Okay, so now what we're going to do is to use our app, and we are select the regression learner, and then the process is quite similar to what we had when we are implement the cases concerning the, let's say, the the classification. So we have the same templates that we open here. We import our data from our workspace. So as we have here, we import our data from our workspace. Then of course we need to select the data set that we wanted. So that is the thank you. Then the model automatically selects the dependent variable that we want to predict, that is remaining useful life. Then the next step is to split our data set in 70-30%. This 30% is a random selection of total number of the samples that we have here. They got random selection 30% for a test data set and 70% for training data set. And now they starting to get the information, and we will plot the information as we have based on the definition of the graph that we have. So we need to just to organize, including here the corrosion, is that the ones that we've got as a result. We already know that. So we have the graph that's the points along the time. So we can see that the remaining useful life reduce as long as the corrosion increase. And then what we're going to do now is to select our model. So we have we need to choose the stepwise regression in here. So here we are, stepwise linear regression, and run the simulation. Then of course we'll see the error of our prediction. So the model are being trained by the 7% of data, the training data sets that we select, have a random selection from the whole data set, and then of course the model will come out with some prediction equation and demonstrated how is the regression. So that's the concept behind stepwise methods. Is very interesting because these methods, different from the linear regression, are able to select the independent variables that more influence on the prediction of the dependent variable. And in our case, we have a pitting degradation, we have a corrosion degradation, we have the temperature, and the model selects the corrosion as only the one parameter that has more influence in our prediction. And that's what we have now. That will come out here, the error of the root mean square error, just want to increase also here, and then we'll see the the final prediction that will be presented here. So here we are. Root mean square error is very low, 3.14. Coefficient correlation is 0.96, very good. And we have also a mean square error, mean absolute error. So all error are very low. So that means the model fits very well to the data set. And then we can see the predicted points and the true point, and we can also now include to see the error margin when there are some difference between what was predicted and what is the real data set. Okay, so now the next step is just to import this data set for our model, and then now we will validate by predicting new data set and look on the error that will predict if the values are closer or not. So now what I'm going to do is to import another data set to try to validate my data. So let's take a look on case study. Thank number 3. So I just import this information. Thank number 3, here we are. Then what I'm going to do is to use this equation to predict the remaining useful life of this new dataset, tag 3. So here we are. We've got a lot of good predictions, so we see that by using the previous model in the new data set, we get a bad prediction. So that means we cannot validate this model. So in other words, we need for this new data set start again the process and define a model. So now let's finish this presentation, this model. So as a conclusion, we need to highlight the points and the drawbacks of the stepwise method. So stepwise methods have the ability to manage large amounts of potential predictor variables. Watching the order in which variables are removed or added can provide valuable information about the quality of prediction variables. So as we saw by explaining the methodology of stepwise regression, and select the predictor independent variable that's more affect the dependent variable prediction, in our case the remaining useful life. And then we saw that even consider temperature, corrosion, and pitting, the corrosion was the one that has more effects on the remaining useful life prediction. That's why the model select only this variable. The drawback is that some variable may be removed from the model when they are deemed important to be included. That's the risk. We can actually eliminate one specific independent variable that is important. And in two predictors variable in the model are highly correlated, only one may make it into the model. So if we can really not consider two parameters, variables, independent variables, even if they are high correlates, maybe the method that eliminates one of them and we use only one. Okay, but even though the stepwise methodology is very good, better than regression, simple linear regression, because these methods are able to select the independent variables that have more effects, are more important to predict the dependent variables. Okay, so these regression methods, the stepwise regression methodology, is described in the book Artificial Intelligence for Maintenance 4.0 in the chapter 7. You can take a look on it and get, if you have later on some questions or some issues with these methods. So thanks again for your attention. If you have some question, just send to me, and let's move to the next model.